Judy roller skate. Whoops, there she goes again. She looks discouraged, and I can't really blame her. That sidewalk is hard. Why is it, she asks herself, that every time I fall, I have to fall down? Why can't I fall up? Maybe if I lived on the other side of the world, I would fall up. No, Judy, no matter where you live, you would never fall up. But which way is down? When we say down, we really mean toward the center of the earth. Remember, the earth is round, and no matter which side of the earth you're on, down is always toward its center. The reason that things fall is that there seems to be a kind of force that tries to pull everything downward. We don't know exactly what this force is, or how it works, but we do have a name for it. We call it gravity. Gravity makes things fall from high places. That's why water flows downhill. Apple falls to the ground. A rock rolls down a hillside. A pencil falls to the table. But what happens when an object stops falling? Does gravity stop pulling it? No, this force seems to be present all the time. If the table weren't there, the pencil would continue to fall until it hits the floor. And if the floor weren't there, the pencil would fall to the ground beneath the floor. An object falls until something else gets in the way to stop it. Even after it stops falling, gravity still tries to pull it downward. The force of gravity seems to work all the time, and it pulls everything. It pulls people as well as objects. It is pulling you right now. What do you suppose would happen if gravity suddenly stopped? You would immediately start floating toward the ceiling. So would your chair. And your teacher. Even your school would suddenly fly upward. In fact, everything and everybody on the earth might go sailing off into space. And soon afterward, the earth itself would go all to pieces. Of course, this will never really happen because gravity will probably never stop. Gravity is the pull that holds everything to this spinning, whirling earth. The Earth's gravity even pulls the moon. If it were not for gravity, the moon would fly off into space, too. How much pull does gravity exert upon you? If it is a force, we should be able to measure it. And we can. All you need to do is weigh yourself. If you say you weigh 58 pounds, what you really mean is that gravity pulls you downward with a force of 58 pounds. Many things that we buy are sold according to their weight. In other words, according to the pull of gravity upon them. Whenever you try to lift anything, you are really having a tug of war with gravity. In order to lift any object, you must pull it up harder than gravity pulls it down. Gravity not only pulls objects while they're at rest, but also while they're falling. Suppose a flower pot were going to fall on your head. Would you rather have it fall from a first-floor window? or from a second-floor window. Yes, if you must choose, you would rather have gravity pull the flower pot from the lower window to your head, because the farther most things fall, the faster they go, and therefore the harder they hit when they land. Do all things move faster and faster as they fall? Suppose we drop a block of wood and a sheet of paper at the same time. Will they hit the floor together? The block of wood falls straight downward, but why does the sheet of paper flutter this way and that before it settles to the floor? The reason is that air underneath the paper supports it and does not allow gravity to pull it down so fast. But suppose we crumple the sheet of paper into a tight little ball. This time, very little air can get under it to hold it back, and when we drop it, it falls almost as rapidly as the heavy block of wood and hits the floor at nearly the same time. This is one way of showing that all objects, light or heavy, fall with the same speed, unless something else gets in the way. Whatever it is, gravity acts like a powerful force, and one that is very useful to us, too. Water flows from a faucet because the lake that supplies the water is higher than the faucet. Gravity pulls the water down through a pipe from the lake to the faucet. Very often we use gravity to help us do work. For example, when we unload gravel or coal or other materials. We may even use gravity when we play. But sometimes gravity can be a nuisance, too. Yes, perhaps gravity is a nuisance at times, but you know how very important it is, too. Of course, there is a lot more to learn about gravity, but from what you have already learned, see if you can answer these questions. How do we use gravity to help pave our streets? In what way does a parachute help to resist the pull of gravity?